Case number 16. We need to verify or check for this given identity. We have the quotient of secant alpha and cosecant alpha be equal to tangent alpha. In order for us to show or verify this identity, we need to come up with the same expressions or identities on both sides of the equation. Hence, we are going to pick which side we need to manipulate. In this case, we are going to manipulate the left-hand side because it has more than one trigonometric identity. The right-hand side is already good as it is, and we are going to make sure that this left-hand side will return to tangent alpha. Now, for some cases where both sides are a little bit complicated, we are going to represent both sides in terms of either sine or cosine or a combination of both. But here, let's just only focus on the left-hand side. We know here that we have secant alpha over cosecant alpha. Let's try to simplify or express secant alpha and cosecant alpha in terms of sine, cosine, or combination of both. Secant alpha is known to be the reciprocal of cosine. Hence, we can write it like this: 1 over the secant alpha is 1 over cosine alpha. This is just the numerator itself. 1 over cosine alpha. That's secant alpha. Now for our denominator, this can be represented by a reciprocal of sine because that's cosecant alpha. In short, cosecant alpha is 1 over the sine of alpha. Now this should be represented in a way that this will be equal to tangent alpha. Since we don't have much space and this process needs another big portion, let's just simply place this a little bit later, and we're going to represent first the quotient of 1 over cosine alpha and 1 over sine alpha into an expression. Now, take note here, we are dividing rational expressions. Okay, this is the first rational expression, your numerator, to be divided by your second rational expression, your denominator. When you divide rational expressions or even fractions, we're going to use here the keep, change, flip method. Meaning, we are going to keep our numerator or write it as it is. Okay, we are going to change the operation of division into multiplication, and we are going to reciprocate our denominator. When we reciprocate a denominator, this will no longer be 1 over sine alpha. When we reciprocate that, it's sine alpha, right, over 1. This is what happens because you are dividing rational expressions. You're using here the keep, change, flip method. We keep the numerator. Instead of our division, we change it to multiplication, and then we reciprocate or we flip our denominator. This time, let me return here the tangent alpha because the goal for checking identity is to make sure that both sides of the equation will have the same expression. Now with this, we are multiplying here rational expressions. Now that we have used the keep, change, flip method, we have 1 times sine alpha is just simply sine alpha. Cosine alpha times 1 here is just cosine alpha. This should be equal to our right-hand side, original right-hand side, which is tangent alpha. Now, even if it's too obvious, let's just simply finish this, making sine alpha over cosine alpha be one trigonometric identity equal to tangent alpha. And that is now equal to our right-hand side, which is the original right-hand side, tangent alpha. And once you reach at this point, we have now verified this given identity, and we have shown that the ratio of secant alpha and cosecant alpha is just equal to tangent alpha. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.